Hi everybody, welcome back to my channel. This is the third episode of the series on the foundations of mathematics. Today's episode is about rounding and estimating. So, what is rounding and estimating? Essentially what we're doing is we're taking numbers that we would use in real life, like when we're shopping, measuring, estimating time. The goal of rounding and estimating is to give us kind of a rough sketch of what the number actually represents, right? Let's say we have something very detailed, a very detailed number, like 5,261.382694. And that's the total price at a supermarket, right? And you come home and your parent asks you, how much did you spend at the supermarket getting ready for this party? Right? And huge party you're throwing, like a wedding or something like that. How much did you spend at the supermarket? And you tell them, I spent $5,261 and 0.382694 cents. They're not going to need all of that information. They want a rough estimate or a rounded value of how much you spent. So let's say they want it really rough, right? The rounding depends on basically how precise you want your response to that question to be. Okay. So let's say round this number to the nearest thousands. So basically we know it's going to be in the thousands, but we don't care how close or how far it is from any particular thousand. We just want to know the total number of thousands of dollars that you spent. So let's round this to the nearest thousands. Well, what that means is what thousand value, 1,000, 2,000, 3,000, so on, what value is this number, is this price closest to? It's pretty clear that you can see it's closest to 5,000, right? It's closest to $5,000, right? The reason for that is, well, we see it starts with a 5, and we also know that on a number line, right, I'll try to draw a number line, here we go. Let's say we're going along the number line, we get to 5,000, okay, and then here later on the number line is 6,000. Okay, well, where does 5,261 sit itself? Well, it sits itself 261 of the way through, the 6,000s. So this would be 261, it sits about here. So it's pretty clear on this number line that we see that this number is closest to 5,000 and a little bit further away from 6,000. Right, so that we're going to round to the nearest thousand. Well, this is the nearest thousand, 5,000. Okay, and this is going to be true for any number on the number line between 5,000 and 6,000. Right, it's going to be true for any number on the number line. I'll redraw it so you can see it. Up until we get to a certain point on the number line when it switches. Right, because let's say we have this is 5,000. This is 6,000. Okay. This number is clearly closer to here. This number is clearly closer to here. Well, where does it switch? Well, it switches, as you would expect, exactly halfway between the two numbers. Halfway between. Now, what number is halfway between 5,000 and 6,000, you might ask? It's 5,500. So this 500, or 5, represents the middle point of every set of 10. Right? We can think about this on a simpler scale. Right? Let's say we were rounding between the number 2 and 3. Okay, so we have, say, 2 here, 3 here. Halfway between it would be 2.5. So anything in this range would round down to 2. Anything in this range would round up to 3. Now, what do we do about the number exactly in the middle? 5,500, for example, or 2.5. Well, that number by convention rounds up. So 5,500 rounded to the nearest thousand would go up to 6,000. Okay, that's just convention. It's actually exactly equidistant from both 5,000 and 6,000, but as mathematicians, we have to pick one, and it makes more sense when you break it down to go up to the larger number rather than the smaller number. So these are the basics of rounding, okay? Now, we can also round numbers at different scales depending on what we want, depending on how rough we want the rounding to be, right? So if I say round this number to the nearest thousand, it's 5,000. But what about rounding the number round to nearest 10. Well, where is the tens place? Well, this is the ones place, this is the tens place. So we want to round to the nearest that number. Okay, so we're at 5,261. The nearest 10 is either 5,260 or 5,270, right, on a number line. Those are the nearest tens. All right, so 261, well, this is 1, it's less than 5, and it's going to therefore round down. So rounded to the nearest 10 would be 5,260, okay? We can also round decimal places instead of whole numbers. So let's round the decimal places. Let's say we want to round to the nearest thousandths. And if you don't remember what thousandths are, you might want to go back and check my place value video at the beginning of this fundamental theorem video. Okay? So round to the nearest thousandths, well, remember, this is the ones. This is the tenths, TH. This is the hundredths. This is the thousandths. This is the thousandths place. So we want to round that number to the nearest thousandths. So what we do is, common pattern here, we look at the next number. Next number over is a 6. So that's bigger than 5. So it's past halfway through this 2 here. So what that means is we're actually going to round up. So we're going to make all of these numbers 0. And we're going to round this number up to a 3. So what we're left with is 5,261.383. That's rounded to the nearest thousandth. Okay, so this is rounding with decimal places or whole numbers. Okay, so let's do an example of a question like this. Estimate the total cost of the following back-to-school items by rounding to the nearest dollar. Okay, so we're looking at the dollar. That's going to be the ones place of the dollars. Okay, so what is the notebook closest to? So here's what we do. We look at the next number over. This is where we're rounding to. We look at the next number over. We see that it's a 4. 4 is less than 5, so we're going to round down. So we're going to round down, keep us at $3. So to the nearest dollar, a notebook costs $3. Let's go to a backpack. To the nearest dollar, we want to round to the ones place. We look at the next number over, see a 9. Okay, so what is 9? Well, 9 is bigger than 5, certainly. So we're going to round up. So instead of saying at $47, we're going to go to $48. Okay, so that's our rounded backpack price. Okay, now let's do that for a calculator. Now we're going to look at 1850. So we see the 8, that's where we want to round to. We look over at the 5. 5 is in that middle ground, it's exactly in the center. So then what we do is we go over and look at the next number, and we see that it's 0, so we're still exactly in the middle ground, right? But what's important is, remember, we talked about how 5 being in the middle, by convention, we round up. So 5, even though it's in the middle, we still go up. That means we started at 18, so we're going to round our number up to $19. Okay? So this is rounding. Now we have a second part to the question. If Elaine buys 3 notebooks, 1 backpack, and 1 calculator, estimate how much Elaine spent. So if this was the question, what we would do is we'd first estimate the price of each notebook, right? And we'd round to the nearest dollar. That's estimating, right? So what we do is multiply the number of notebooks by their cost. So 3 notebooks times $3. That gives us $9 worth of notebooks. Okay, then we need 1 backpack for $48, so we have to add $48. Okay, and then we have to get 1 calculator worth $19, so we have to add another $19. So we're going to add all these up. We get 9 plus 48, that's 59. 59 plus 19 gives us 78. So we're going to get a total of $78 spent, and that's an estimation. The real value is different because the notebook doesn't cost 3, it costs $3.49. The backpack doesn't cost at 48, it costs $47.99. Right, so we're a little bit off, but if somebody asks you, how much did you spend on school supplies this year, they're not going to be looking for the closest exact value. What they're really looking for is about how much did you spend, right? Well, I spent about $78, okay? Or Elaine spent about $78, Okay, so this is an introduction to rounding and estimating. Leave a comment if you want me to explain something more clearly or go over a different topic. Thank you for coming, and I'll see you in the next video.